Good morning, guys. So today we are going to be working on volumes of prisms, which is the next step. So we worked on surface area, now we're moving to volume. You've done volume of some of the prisms that we're going to look at today, but we're going to add in a couple of new ones. So last year, you pretty much dealt with volume equals length times width times height. And then they started to add in the second formula, which is the area of the base times the height. So capital B stands for area of the base. Now we got to be a little careful when we start looking at variables. Whether it's lowercase or uppercase actually matters. Okay. Before this, it really didn't as much, but now it really does. So capital B refers to the area of the base. Lowercase b is just the base. Okay. So basically what happened is last year you pretty much dealt with rectangular prisms. If they challenge you, they might have given you triangular prisms. So in sixth grade, if you were in sixth grade math, what happens is now you would do a rectangular prism, but with fractional sides. Right, and this is just the formula, but base times height. Okay. Now we're going to look at a few other different shapes, even in a rectangular prism itself. What happens if it's slanted, that type of thing. Okay. Again, it's the same thing, area of the base times the height. Oops. Now we're going to look at a few other kinds of prisms. We got triangular prism, hexagonal prism, it's a different kind of triangular prism. It is heptagonal prism. All right. So we're just going to look at what did you do last year? Not very complicated. Okay, so volume equals the base times the height. So it's going to be important to write this down on a piece of paper just to be in the habit of it. I'm not going to make you turn it in, but you'll see what happens. So volume equals basically the base is length times width times height. Plug in the numbers, and the volume is 720. Now you got to make sure you label properly. So in volume, it's always going to be cubic units because we have a length, we have a width, and we have a height. So we have yards length, yards width, yards height. So that produces yards times yards times yards, which is yards cubed. So 720 yards cubed. Not very complicated. You could have done that without me showing you. Now let's look at this one. Okay. So what do we have? We have a parallelogram as the base, and then we do have a height. Now it looks slanted. That's fine because that's parallelogram, but we still have the same height here. They gave it to us as 6 centimeters. So volume equals the volume of the base times the height, the area of the base times height. Now, here's where it gets a little complicated. When we're writing it a little bit more specific, now we have the little base here, little b for base, and then we have two different heights. You have the height of the face, and then you have the height of the object itself, okay, or the prism itself. So the base is 8.5, the height is 5, and the height of the face is 5, and the height of the whole object is 6. So that comes out to be 255 centimeters cubed once you've done that. Now when we're looking at a triangular prism, not much different. So again, it's still the volume is the area of the base times the height. Never changes. The only thing that changes is what formula do you use for the area of the base. So area of a triangle is 1/2 base times height. Now we know that's the area of, now remember the base and the height in a triangle are the two sides that form the right angle. So 1/2 base, and now I just label them as height 1 and height 2. I could have done a little bit different. I could have done the height of the face, height F for height face, and I could have done H P down here for height of the prism. Doesn't really matter which way you do it. Whatever makes sense for you. I just wanted to show you the difference between the two different heights. Plug the numbers in. Base is 5.5, height is 2, height of the face is 2, height of the prism is 4. Multiply that together, you get 22, and then it needs to be labeled properly, inches cubed. Now we have, again, another triangular prism, but this is a right triangular prism. Again, same formula, 1/2 area of the small base times the height of the face, well, the base of the face times the height of the face, then the height of the whole object. So the base and the height are 6 and 15. The height of the prism is 8. Multiply those together, 360 feet squared. I'm sorry, feet cubed. Now, when you get to shapes outside of or bigger than a quadrilateral with the face, they tend to give you the base. Now, there's a way to figure this out because basically we're going to get to this later on, but each face or in each shape, as long as it's a regular polygon, you can actually divide it into triangles. But we'd have to give you a couple different measurements for that, and we're not going to really get into that one for today. Okay, so the volume equals the area of the base times the height. So the volume of the base here is 197 millimeters squared. The height of the prism is 25 millimeters squared. Multiply that together, 4925 millimeters squared. Not overly complicated. Again, it's just using the formula that you are given. This one's a little bit more involved. It's kind of neat. It's a nice little application for the real world. So people who are selling popcorn, they want to give you 96 cubic inches of popcorn. So which bag should the movie theater choose so that they use less paper? Okay, so now with the green movement, people want to use less of whatever it happens to be. So to get the maximum amount of volume with the least amount of paper to do it. So first thing we need to do is figure out the heights. We do not know the heights of these. We know that the volume is 96. So again, we start with the formula. Volume equals base times height, area of the base times the height. Now we know the volume is 96. We don't know the height, but the area of the base is 4 times 3. So then we go ahead and we solve it, divide 12 by both sides, and we get a height of 8 inches. I know I didn't label it. That's fine, because I did it here. Okay. Area of the bag B, same thing. Instead, we just plug in a 4 here instead of a 3. Divide 16 by both sides, and the height is 6 inches. So A has a height of 8 inches, B has a height of 6 inches. So to figure out how much paper we use, we need to find the surface area. Now, you remember there was a formula for surface area. It was 2 times the length times the width, plus 2 times the length times the height, and then 2 times the width times the height. You notice I didn't put a 2 here because with the bag, there is no top. So since there's no top, we do not include paper for there. Okay, so that's why it's just length times width plus 2LH plus 2WH. Plug all the numbers in. So the base was 4 and 3. The height was 8, right? And then we just plug those two in. Comes out to be 124 inches squared. And notice this is a square term because this is surface area, not volume. Bag B, okay, again, it's the same exact formula. We just change out the 4 for the 2 3s. Go through, and it comes out to be 112 inches squared. So if they wanted to use less paper, they would have made it more cubic. All right, so good luck. If you have any questions, please reach out to me.